Hello, my name is Marco Delgado, and I'm an industrial engineering student, master's degree. And this is assignment 4 for IE 490, sustainability. It's on homework number 4, option 4, which is create a video where I talk about a biopolymer. And for 5 minutes, I'm going to try to do 5 minutes. I'm going to discuss the name of the biopolymer, applications, benefits, how it's made, and other topic of my interest. So, just to let you know, I have 20 years experience in the medical industry, working for Johnson & Johnson medical devices, specifically surgical sutures. So I will be talking about surgical sutures and applications and different materials, and specifically for biopolymers. So, I'm gonna start off by what is a biopolymer. Biopolymers are polymers which are naturally found in nature. Similar to polymers. Biopolymers are chain-like molecules made up of repeating chemical blocks and can be very long in length. So, but when we say bio, it means that they are produced by living organisms, and thus it's biodegradable. Um, they're classified into different groups depending of the nature of repeating units that they are made of. First one are the polysaccharides, which are made of sugars, proteins of amino acids, and nucleic acids, nucleotides. Some examples are cellulose, which are found in plants, myoglobin, which is muscle tissues, and DNA, which is genetic material of a given organism. So, in difference to synthetic polymers, um, which is much simpler and more random structure, biopolymers are more complex, molecularly speaking. Um, so, the polymers can be derived of some petrochemicals and chemical processes, whereas biopolymers produced from renewable resources such as plants and living organisms. So, which means that they can be degraded by natural processes, microorganisms, and enzymes down to the element entities that can be reabsorbed into the environment. So, in this case, for sutures, biopolymers offer the possibility to create a sustainable industry and reduce CO2 emissions. So, talking about surgical sutures, what is a surgical sutures? Basically, it's the ability to connect two sides of a wound to enhance the rapid healing. So basically, it connects the wound to speed up the healing process, which is called the hemostasis. And this has been going on for too many years. Back to the ancient times, Rome, they used to use a lot of sutures of different types, naturals and for mummification. So same as Greeks and Romans. So suture has been around, too long already. So. Just to talk a little bit about sutures for my company, I have some samples that I collect, and for example, this suture in this packaging, glass packaging, it was from the early 1900s. It's a horse hair, so it was used to help out the healing process, right? Another example I have here, this is like for the 1940s, which is surgical gut, cat gut, which is basically from bovine intestines or sheep intestines. So those are some of those natural absorbable. One is natural, both are natural. One is absorbable, non-absorbable. I have a polymer here, polymer-based suture, which is called Proline. It's a blue monofilament from polypropylene. So these are some of the sutures. So now the industry is focusing more into biopolymers, and I have a couple of examples about biopolymers. There's a company that FDA cleared a biopolymer suture a few years ago, which is made of materials that the human body produces, right? So we ourselves produce that chemical, which is polyester, and it's produced naturally. So what it means is that it can be absorbed naturally by the body, as the wound is healing. So as you know, when we put something foreign in our body starts rejecting it. So having a polymer or something made from our body, so it's easier for the body to accept it, and it speeds up the healing process. So an advantage of these is that it's like it's a natural polyester produced by the body. So this one, it's 30% stronger than the sutures that they're currently out there, the polymers or the synthetic absorbables, which those are prone to reopening the wound, and so it's stronger. So the absorbable sutures are the first made from material produced genetically modified bacteria, so which is natural compounds synthesized by those bacteria. So when the researchers were working on the research, right, they focused on their biopolymer engineering efforts on a group of genes that code for enzymes in a pathway to produce polyesters, right? So those polyesters can be broken down into metabolites naturally produced by humans. So they cause no harm when absorbed, because our body does not reject it compared to other stuff in our system. So once the genes were identified, they could be transferred into a strain of industrial E. coli that can produce large quantities of the strong flexible polymers for mass production. So this has been cleared by the FDA, and it also, aside from sutures, it can also be utilized in other medical devices applications, such as surgical mesh, multi-filament fibers, and stents. Stents, you can do for arteries, and also surgical mesh for hernia repairs. So that's the advantage. So another ongoing, let's say, another ongoing activity or project, it's by another company, is they're trying to develop a monofilament, which is one single strand absorbable suture with 50% retention strength, 3 months after implantation. So in my companies, we have a chart, of all the different sutures which are absorbable. So each suture has different applications, such as gastrointestinal, orthopedic ligation, facial closure, etc. So each has a different absorption rate, or depending how many days the body takes to absorb it, during the healing process. So for this particular suture that's been developed right now, it's expected to meet an unmet need in the suture market, for a device that can provide longer term wound support, which is very critical for the well-being of specifically people with diabetes. They take a long time to heal. So when they go surgery for a normal suture, maybe the suture at times is absorbed before the wound heals, because the diabetic people tends to heal much slower. Also, it covers the market for people with compromised immune systems, nutritional impairment, obesity, or conditions that compromise the wound healing, such as infections. So this suture is also expected to find an application in fascia closure. It's a much thicker skin, and it needs something special. So, and also in orthopedic procedures for ligament and tendon repair, which is also critical. The approach for this particular new suture involves a new proprietary absorbable biomaterial known as poly-4 hydroxybutyrate, which in short P4HB. This specific aims at the project, or the aim of the project, are produce an extrudable form of P4HB. So extrusion, to produce a monofilament and also to optimize the production of monofilament. In addition to that, prepare the sutures. Identify the suture properties. It's very important to have the suture properties identified to make sure it's compatible with the surgery that's being used for. Another important part of this is determine the in vivo strength retention. So the in vivo strength retention is basically implants suture on rodents, to make sure that's called in vivo. It retains the sutures enough time, by as the wound heals. Also, evaluate the suture's biocompatibility. So, biocomp studies are performed to ensure that the product is compatible with the body. The body is not rejected. So, it's also implanted into rodents or mice or rabbits. So, make sure that the body does not reject it. That's before it's implanted into a human being. And also, to demonstrate the surgical functionality of the suture, and they analyze the biodistribution and pharmacokinetics of the P4H. And also, important to determine the suture stability and shelf life. It's very important, because a lot of times, the suture is out on the shelf for 2 years. So we have to make sure, it's the suture is still, it's not compromised, as time passes. So this is basically my presentation. So I hope you enjoy it. I get very passionate about it. So you have any questions, feel free to contact me. Thank you very much. And again, my name is Marco Lito.